Okay, so let's do the second experiment. Not the second, we'll do the third one. There's a stable multivibrator using transistor. Okay, so let's open the keycard, create new project, and let's name this stable multivibrator, and can be saved in keycard directory. Save. So we have two files, PCB and schematic. Open the schematic, and I think you are familiar with the circuit. So this circuit is this. So you have four resistors, two capacitors, and two transistors. Okay, so let's place all these components and draw the circuit first, and then we will put the values correctly. Okay, so the circuit is like this. So let's first place the components. So go to this, place symbols, click and click on the schematic. It loads the library, and go for the PSpice library. That's it. Okay, PSpice library, and first of all let's place the resistors. Resistor 1, 2. Let's zoom in a bit. Okay, so we placed four resistors. We need two capacitors. Click on this spice library, capacitors, double click. Let's rotate this. It will be placed, so here again the capacitor, rotate and place here. And let's, what else is there? We have the transistor. So it's an NPN transistor. So transistor on here, and one more transistor. Let's rotate it, orientation, let's mirror it about the vertical axis. So let's zoom in a bit. If you can orient all these things, and your circuit looks nice. Okay, so let's select this and place it in a better way. Okay, so let's select this and be here. Select this. Looks nice. Okay, now we need a ground from the spice library. So the ground we place here. Then we need a voltage source from the spice library again. So let's have this source. let it be here. So here in this case is an astable multivibrator. There is no actual source, it's just a power source. So this will somewhat be like a power supply. So now let's connect all these things. So the connection, like this, click here. Now click. Click, click, click. Let's connect all these things. So whenever there is a junction of wires, there will be a dot. If the dot is not there, it's not a junction. You have to be careful about all these things. Click here. So the wires have been connected this way, and this is the common ground. It can be connected with the ground. Okay, so now the point is, from here we have to connect it to the base of the second transistor from this point. So there is, so let the, how can I, so let's draw like this. Okay, now from here, okay, so that completes. See, actually we don't have a junction here. That means this wire is not connected with this wire. Okay, so that's right. So be careful. If you are making a junction here, you are making a mistake. Okay, so now this can be connected with this one and this to ground. Okay, so this completes the design. Now we have to annotate. Okay, in order to name the components. Now R question mark, all these things are there. So click annotate. See, R1, R2, R3, R4. These resistors have been named, capacitors have been named, transistors Q1, Q2 have been named, source have been named. So everything has been named by this annotate. Then you can check this electric rules, whether you are violating any electric rules, any unconnected, unintentionally unconnected lines or points are there or not. So some pins are not connected, yes, but they are actually, they may be the, oh, pin for the input component of Q1, Q2 pins. Some pins are not connected, those are not shown as errors. And this is the power input, that's okay, but there are two transistor pins which have not been connected to any nets, so that are these lines. Yeah, these arrows indicates the points of warnings. So let's mark a disconnection here and here and run the ERC again. Okay, so two warnings have been removed. This is about the warning that the power source, voltage source, is connected to ground. That's okay. See, actually there is a fourth pin for the transistor. See, there is the substrate. Some transistors will have this kind of a pin which has to be connected, which may be connected to some common earth point or the common reference point of the PCB board sometimes, but let's disconnect it. Okay, so this completes our stable multi vibrator. So next see, we are not using any of these tools. These are actually meant for the PCB design. So let's if I release one more video, I will detail all these tools and how to make the PCB, how to design the PCB. Okay, right now we are not covering that. Okay, so this completes the circuit. Now we can set the source. Double click on this. So source is supposed to be a DC, so let's give 9 volt, fill value 9. Okay, I think we need to give 9 volt V also. Okay, let's see. I'm a bit doubtful about this. And the values of these resistors and capacitors should be properly given. Where is it? There was an astable multiplier. Yeah, this one. Okay, so this is 4.7k and 82k. 4.7k, so this is 4.7k, 4.7k. Okay, this is 82k, 82k, this is 82k, this is 4.7k. And what about the capacitance values? 0.01 mu, 0.022 mu, 0.01 mu is U. Okay, and this is 0.022 mu. Okay, so that's it. So we have completed all the component values, transistors, voltage source, etc. Now in the tools we can go for the simulation. So choose the simulator, then about the settings, go to transient. We are observing the time window which is given here. So time steps can be 1 millisecond, but if you give 1 millisecond of the time step, it will be too small for this. So let's give 100 microseconds. Final time maybe some 100 or 200 milliseconds, starting from say some 180 milliseconds. So we are observing a window from 180 millisecond to 200 millisecond with time steps 100 microseconds. That means 0.1 millisecond, because we are expecting say this is actually a 1 kilohertz astable multivibrator, means 1 millisecond period. So we cannot give a very small time step lesser than 1. It should be at least 1 by 10th of the duration, means 1 by 10th of 1 millisecond or lower should be the time step. Otherwise we may not be able to observe the waveform properly. Let's just see what happens. Okay, then go choose the probe and choose the waveforms, tools, simulator. So we have to run it, that I forgot to do. Okay, so it's taking too much time. It's, see, this button is red, so it's simulating, it keeps on simulating. So I think our settings are not correct, so let's stop this, change the settings. So this duration, let's give 1 millisecond time step first. Let's see. So now it finishes. Prog, waveform, tools, again go to the simulator. Okay, so it builds the waveform. So this time is not enough, again go to the settings. So 1 millisecond, this may not be okay. Let's give 100 microsecond itself, and let's shorten this observation window, let it be 195 milliseconds to, or let's give some 20 milliseconds, or let's give some 50 milliseconds, from 0 to 50 milliseconds. Let's see how it is. Still taking too much time. See, it is only simulated up to, so 5 minutes. Now it stops. See, green here. So it stops, and you have this, the output waveform like this. Okay, so we just need I think we just need a window from, say, 15 milliseconds to 15 to 25 is enough. So let's close this and redo everything. So tools, simulator, settings, transient, time steps can be 100 microseconds, final time can be 25 milliseconds, initial time can be 15 milliseconds. Seconds. Okay, start. So it takes a bit. Okay, so see, it has created a data set of 26,000 values, 26,000 number of data set. That's why it takes too much time. So take the prompt, click here. So you will observe the collector waveforms for both the transistors. Okay, tools, simulator. You see this is the waveform you are observing. So it's an astable multivibrator. At one point you are getting a square waveform, and the other one it's a slowly charging waveform. Okay, so it's correct, right? It's an astable wave. So let's check the base waveforms also. The base waveform of the second transistor. Tools, simulator. See, the base waveform is like this. So again we can see the base waveform of the second transistor, first transistor also. tools, simulator. Okay, so it's in yellow color. So these are the different waveforms of the stable multi-orbiter. So it's done.